it's very good that people really think ChatGPT is artificial intelligence, because I think, to me, that tells me one thing. At least people took notice of all the work that had been put into this particular field over the years, and at least they can resonate with a product of that. But then, to really answer your question, ever since people made computers, from the times of Turing, people have always wanted to replicate themselves. As human beings, I think it's a very fundamental aspect of us to want to replicate the gods and to create our own different versions. So from the invention of computers, we've always wanted to see, can we make computers that can think? So really, that is the genesis of where artificial intelligence comes from. What ChatGPT is really doing is trying to predict what is the most likely word to come after a certain particular word. So think of a sentence of, let's say, the car drove on the dash. So you're trying to come up with what is most likely that the car drove on the dash. Now that dash, you don't know what that is. So what ChatGPT, a model like ChatGPT is doing, is trying to predict what is that particular word. So there's a number of words already you know of. There could be, let's say, water, road, any kind of word you can think of. What those are represented as vectors in a vector space. So what you're trying to basically do is to try and see what is the most, it's assigning probabilities to the various words and seeing what is the most likely word which should appear after such a sentence. The car drove on the road, in this particular case, will probably be a very highly likely probability for something for you to complete that sentence. So the words in this particular case are taken as tokens. I think in the African setting, we understand the issue of fire and children playing around with fire.
Oh, yeah, sure.
So what happens is when a child goes and maybe touches a fire or something which is hot, it burns them, right? So there's a cost function you're putting into this particular machine. What this means is that if the machine does something which is bad, the reward is very low. You punish the machine. And if it does something which is good, you give it a higher reward.
This is the Policy Digest, a Center for Policy Analysis podcast that explores how African societies are governed and how people and their leaders are shaping the future of their communities. Through candid conversations and insightful analysis, we aim to provide a deeper understanding of the political, economic, and social landscape of Africa. So sit back, relax, and get ready to explore the diverse and dynamic world of African governance.
From the beginning of time, Africa has always received civilizations, from the Industrial Revolution to colonialism to the current hemorrhage that is surrounding neocolonialism. You can tell that we always at the receiving end. We wake up after it has happened, after they have sold us a mirror and we've sold our sovereignty, or after we've known that this works elsewhere and then we have to adapt it here. And this always brings the rush you see from the 1980s with the structuring programs of the Bretton Woods institutions, so 2001, 2002, 1998, thereabout, with the World Bank restructuring programs. We're always saying this has worked here, so let us apply it here. And the idea is we always come late to the party. And again, we always come late to the party. And one of the current civilizations that are evolving, and which I think started way, way wrong from the days of Alan Turing in the 1970s, is the fourth industrial revolution, which has given birth to artificial intelligence. So in this podcast, which is the Policy Digest podcast, where we profile African leaders and ideas that are shaping the future of the African community, we want to discuss whether Africa is coming late to this party, the party of artificial intelligence in the fourth industrial revolution. Just sit back, relax, take a cup of coffee or juice or bushera, whatever you want to take, and we're going to dive right into the conversation. So in order to do that, we're joined by a renowned speaker and software engineer within the Kampala tech community, and that is none other than Jerry Anguzu Vance. Is that the order in which they pronounce your name, or we start with Vance?
I think it's that's okay. Though usually I'd prefer to call myself Jerry Vance Anguzu. Yeah.
I have just it has just crossed my mind. Your name has a resemblance with the current vice president of the United States. But just to start off, Jerry is a founder, a software engineer, and has a background in computational thinking and data science. He also has a background in programming using Python, smart analysis, machine learning, artificial intelligence, algorithmic design and techniques, cloud platform, big data, and machine learning fundamentals. He has a background from the Massachusetts Institute of Technology, which is one of the leading institutions on technology in the world, and his experience with technology has led him to start fintech known as Everpesa Technologies. He'll be telling us more about his journey as we forward into the conversation. So Jerry, let's maybe start from where you got your interest in technology before we can get into the gist of the chat.
All right. Thank you so much.
And how you come to start Everpesa.
All right, cool. Thank you so much for that very eloquent introduction, Joseph. And maybe I'd like to add on one other thing. Actually, I also have a background in statistics. I have a degree in statistics, and that is really important, especially for the AI realm, because statistics and mathematics is really the foundation of what the current artificial intelligence really is. So I always had an interest in technology, and that really stemmed first mostly from aircrafts. I loved aircrafts from the time I was a kid, ever since I can remember. And so I remember one of the things I did is after I got an encyclopedia, letter A, which is A would stand for aircraft, aviation, aeronautics, astronomy. So I made sure I read anything I can possibly find about aviation, which really interested me in the technology and really that particular field. So to me, I always knew that this is something which I am passionate about, and this is something that I'd always want to pursue moving forward with my life. Fast forward, I really started taking a lot of interest, especially in the financial field. You know, as you grow up, your interests keep shifting. I didn't lose my interest in aviation, but I also started taking interest in the financial field. And from the financial field, I started reading about events such as the 2008 financial crisis, reading about the subprime mortgages, the derivatives, and really understanding all that kind of markets, understanding more of things such as the Black and Scholes models and all that. And I found that really be very interesting, really the field of financial engineering, which was really something that I think resonated with me a lot, because I really wanted to understand how can science and mathematics be used in innovation in the financial sector. So from then, I always thought I actually now really want to get into the financial industry and the banking industry in particular. And as I kept on exploring more into this field, one of the things I realized, one of the avenues that all the avenues finance was moving into is really technology, because technology was now becoming a very big enabler of finance and financial markets. And that really now started getting my interest into the particular technology field and seeing how actually all these systems built up. Banks have, whether you talk about mobile applications, how do those actually work? How do you go to an account in a bank and they know this is how much money you have, and not less, not more, but this is the exact sum of figure you have? That is all really a technological revolution. Look at the various financial products which we have currently, whether you're talking about derivatives, forwards, options, and that entire spectrum of financial products. These are all things which mostly exist virtually. Very good examples, for example, in the commodities markets. So when you look at something like oil, the volume of oil which is traded on the commodities markets is much, much higher than the actual volume of oil which is in the real world. It's the same thing with gold. There's much more gold which exists on the stock market than there is actual physical gold. So it's really all paper, and those are the kinds of innovations. I think they're good innovations.
Is that the same with money?
Yeah, I think it is the same with money. There's more money on paper and in computers, really, the digital kind of money, than there is actual physical cash that exists, which I think is really something that I got so much interest in, especially in the financial field. And really, this is what eventually leads me to, I always knew I wanted to do a fintech startup, and really this is how Everpesa Technologies comes about. And what it is, we're a software company, financial software company, and what we build is software solutions geared towards SACCOs and microfinance institutions. So what we offer is a core banking platform which really helps SACCOs and microfinance institutions to help manage all their various activities, whether that is the savings, the loans, and really to help them to basically give a platform to a SACCO for those who don't know, a SACCO is really a savings and credit cooperative, which is similar to a credit union, which is a community institution where people come and save. So what we are giving them is a platform where they can do all their banking, which is similar to what the larger banks have. The larger banks have, yeah.
Okay, so are there any specific products that have emerged out of, or that, you know, like there's always like a product which is in the market that, let's say, a certain MSME or let's say like, I think Tier 5 or Tier 4 financial institution can procure?
Yeah. Our core product is Safari Banking, which is a core banking system, which is the one which is used for all these various transactions.
Okay. I think the viewer now knows a bit about what you do and your background. So let's forward into the conversation on artificial intelligence and whether Africa is missing the AI revolution. Could we start with basics? What's artificial intelligence? Most people think ChatGPT is the entire summation of what artificial intelligence is. Do you want to take us broadly about what AI is?
Yeah, that's a very good question. I like that we really go back to the basics and start from the very beginning. One, it's very good that people really think ChatGPT is artificial intelligence, because I think, to me, that tells me one thing. At least people took notice of all the work that had been put into this particular field over the years, and at least they can resonate with a product of that. But then, to really answer your question, ever since people made computers, from the times of Turing, people have always wanted to replicate themselves. As human beings, I think it's a very fundamental aspect of us to want to replicate the gods and to create our own different versions. So from the invention of computers, we've always wanted to see, can we make computers that can think? So really, that is the genesis of where artificial intelligence comes from. Can we make computers that can think? Can we make computers that can do? Because what is a computer? Fundamentally, a computer is simply a machine which follows instructions. So you program it to follow a set of instructions. Do this, and do that. And that is really all it does. It never really goes out of that. But people have always wondered, can you actually program this machine to think, to come up with new scenarios and all that? So that is really where the genesis of artificial intelligence comes from. So it is a very broad field currently, which has a number of branches in it. But fundamentally, what it goes to, it is the urge of humanity to try and train machines how to think, to try and replicate the gods. I think that is how I define artificial intelligence and what it is. So we are trying to replicate the gods, or try to teach machines how to think using a number of methods. So using a number of methods. Now, there have been a lot of ways that people have tried from the very start. People try to use some of rule-based systems to try and put in scenarios, if statements, if you're familiar with code, like, if this is the scenario, do this. If this is the scenario, do this. But this is really not intelligent. This is simply programming a sequence of ifs and
it's instruction and output.
Yes, instructions and output. Yeah. So the thing is, that can't adapt to new scenarios. If something changes, that cannot adapt.
You need to have to reprogram the computer based on
reprogram it. Yes. Yeah. So there's so many different ways that have been done, trying to use a bit of heuristics, introducing heuristics into the system. I think this was really most commonly, famously done by, I think, Richard Feynman. So over time, people really try to see, how can we make computers think. The most notable one was I think researchers, I think Frank Rosenblatt, I think in the 50s, who came up with the Perceptron. So what a Perceptron really is a single layer neural network. A neural network, what it means is you put in data you feed the computer with data, and you try and see what are going to be the outputs. So take an example for image classification, for example. So you have photos of men and photos of women. So what you're trying to do is to teach the computer in terms of recognizing that this is a woman, female. This is a man, like female or male. So you keep feeding them photos of females and photos of males. So the computer tries to work out what are the various features in these photos, which are characteristics of males and characteristics of females. So that over time, when you now feed it a new photo of someone a new photo which wasn't part of the training set, it can now tell that this is a male or this is a female. So that was really pioneered through a Perceptron. Now, by the 50s and moving forward, there was really not enough data and compute power to make this kind of work completely possible. And AI's whole field went into what they call the deep winter of AI, whereby no one really wanted to work in this field because it seemed to be a dead end. Yes, the deep winter of AI. It really looked like a dead end because there was really not much progress that was actually coming through. It is, but then when we say no one,
a dead end.
Yes, a dead end. But when you said no one who really wanted to work in this field, of course, there were a number of researchers who kept working at this. I think the most notable ones are people like Jeff Hinton from the University of Toronto, who really kept on pursuing the idea of neural networks. So what they did is they make a multi-layer neural network, which is getting a Rosenblatt single perceptron and really adding more layers to it. So you feed the network from one set, and that set feeds another set and another set. So really having that whole multi-layered neural network, which is really what eventually came to be the kind of artificial intelligence that we have right now. So using that kind of neural networks, there's a number of things which happened. I think now the first self-driving cars, which were brought about, I think in the 80s, the first test of self-driving cars. You have people like Yann LeCun, who made character recognition, I think in the 90s, whereby a computer could now read digits and letters. So a lot of these things started being possible. But I think the real takeoff of AI starts about 2006 or 7, around there. And what is different about this here is now the internet has really exploded. The internet has exploded in such a way that now the data which was initially not available to train these models, and that's the reason why these models were really not working out, is one, there was not enough compute in those days, and there was really not enough data to actually train the models. So once the internet really explodes up and now there's a lot of data which is available, these models start making sense. A neural network actually starts doing what it is supposed to do, and then this eventually takes off. And from then onwards, that is when you're able to see things such as Google Translate, whereby you use Google, you can maybe read a magazine which is in another language, maybe French, but Google is able to translate that for you in English. You see Google Image Translate, you can point your phone at an image and the computer tells you what it is. Maybe this is an orange, this is a ball. And computers now started really becoming better at recognizing some of these various patterns and all in the world. And really that is when artificial intelligence really starts taking off. Really when the data now starts becoming available, the compute power is now available, and the world now starts really moving on. And so this is really what I think artificial intelligence is.
Oh, I think that's good history on how it evolves and how the internet makes for the possibility of applying these historical inventions to just even take off. Are there distinct classifications for artificial intelligence to say that these are the types of artificial intelligence that exist that we can refer to?
Yeah, so it's a very broad field which has a number of different branches to it. So I think the most common one is really machine learning. Machine learning is really similar to what I've already described. You're trying to teach a machine to learn, feeding it data, and then try to see what are the various outputs. This falls into various other categories. You'll have things what I've described, for example, is what we'll call image classification. You're trying to classify images. And so there are other fields of machine learning. You'll have another field which is reinforcement learning. Reinforcement learning is trying to teach a machine how to think, but not really by feeding it a lot of data, but trying to make the machine learn from its own environment. And so how you make this...
Give me like an example.
An example of...
Let's say like in a factory setting or in a real world scenario.
In a real world scenario, yeah. Let me use a simplistic example. Let's say you are trying to... I think in the African setting, we understand the issue of fire and children playing around with fire.
Oh, yeah, sure.
So what happens is when a child goes and maybe touches a fire or something which is hot, it burns them, right? So there's a cost function you're putting into this particular machine. What this means is that if the machine does something which is bad, the reward is very low. You punish the machine. And if it does something which is good, you give it a higher reward. So what this over time does is the machine starts to learn that actually you need to do things which give you a reward and not things which give you a punishment. So now in mathematical terms, a reward could simply be something as simple as you give it, think of it like a point-based system. You can give it a 1 if it does something good, and you give it a 0 if it does something bad. So if you put a machine, for example, in a factory setting maybe, and you're trying to make it, let's say you have a robotic arm and you're trying to make it carry one cup and put it in another place. If it comes and hits the cup and it falls down, you give it a 0 because you punish it because it hasn't done the right thing. But if it actually grabs the cup, then you reward it. Then it's over time, it starts learning what we are supposed to do.
This is a positive behavior.
Is the positive behavior. This is a negative behavior. So using that kind of analogy, really, that is what reinforcement learning is trying to achieve by rewarding a system for what you quote unquote positive behavior and punishing it for negative behavior. So that over time, it then learns that this is the kinds of behaviors that it should do. Is that the same?
Say, I know, like I think all Tesla gigafactories are, I think for most of the work, it's now done by machines. Is that the kind of training they give them?
I do not have the specifics of what is done in the Tesla Gigafactory, but I'd imagine it's a lot very similar to what is really done, especially in terms of training the robotic arms in working. Now, maybe some of the differences, theirs is quite precise work, and it's something which can simply be replicated in a lot of ways, but really the cornerstone to it is this kind of application.
Machine learning. So that's machine learning is one. Is there any other type?
There's reinforcement learning, which is like what I've described. There's deep learning, which is one which actually needs a lot of huge amounts of data, because things like machine learning can do it with small data sets and all that, but things like deep learning, now you need a lot of data to come into it.
So it's what's deep learning?
Deep learning is it's similar to what machine learning is, but it's the only difference is what you're doing is you're feeding it with massive amounts of data, and you're having multi layers of the neural nets into the particular system.
I get that. Which means like the advanced.
Yes.
Advanced. Yes. Are there any systems that at the moment depend on deep learning rather than basic machine learning?
I think a lot of the most real world applications actually depend on deep learning. Some of the most notable ones which we've seen over time is, for example, the Go playing algorithm that I think DeepMind came up with. That is really a deep learning kind of system. And a lot of the applications, because like I mentioned, when data are now started becoming very massive, a lot of companies, especially in application, started using actually deep learning models, which really are more fine-tuned to these particular cases. Even the cases of a lot of self-driving cars, a lot of these are really deep learning neural networks that are being employed to try and make these kinds of systems to work.
Okay, so machine learning, deep learning. Is there any other? Or we can say every artificial intelligence at the moment falls just within.
It falls mostly through those kinds of brackets. There are a lot of
like
other subtleties.
I realize you haven't even spoken about it. It's like at the end of the day, no one wants to speak about it. Like how does that come into play? Is it basic machine learning? Is it deep learning? Where does it fall?
So ChatGPT, a large language models. So you see, these particular categorizations are simply in terms of the methods. Some of the methods which are used to achieve things. So in practice and in application, you're not necessarily only basing on one particular method. You're having a combination of various methods to really come and achieve.
To come up with ChatGPT.
Yes, to come and achieve with.
So like at the background of ChatGPT, what does a backbone have?
No, ChatGPT, what it is a predictive model. And maybe just to give a basic explanation or understanding what ChatGPT is say, let's take a sentence. What ChatGPT is really doing is trying to predict what is the most likely word to come after a certain particular word. So think of a sentence of, let's say, the car drove on the dash. So you're trying to come up with what is most likely that the car drove on the dash. Now that dash, you don't know what that is. So what a model like ChatGPT is doing is trying to predict what is that particular word. So there's a number of words already you know of. There could be, let's say, water, road, any kind of word you can think of. What those are represented as vectors in a vector space. So what you're trying to basically do is to try and see it's assigning probabilities to the various words and seeing what is the most likely word which should appear after such a sentence. The car drove on the road, in this particular case, will probably be a very highly likely probability for something for you to complete that sentence. So the words in this particular case are taken as tokens, right? These are the tokens that the model is being fed on. So once it now has the car drove on the road, it will feed that road back into the model. Now the model is trying to predict what could possibly come after the word road. So you could say the car drove on the road, and that is a very highly probable sentence.
So the AI just extrapolates the sentence.
It extrapolates the sentence and feeds it
asks
back in the model and tries to make a prediction of what is the most likely word to come after that particular one. And this is made possible because this is a model which has been fed on so much data throughout the history of the internet. You get all contents, all movies, for example, you put that data inside, a number of books which have been written over time, you put that inside, and all the content over the internet. So it starts to see how are actually people forming sentences. What are the probabilities after this word? This is the next word which appears, which is really what makes it appear very intelligent and very, very smart. So this is really how a lot of these large language models actually, such as ChatGPT and a number of others, actually work.
Wow, that's quite amazing.
But fundamentally what it really goes back to is really predicting probabilities of how likely is one word going to appear as compared to another word, and that simply goes back to the mathematical foundations I really talked about at the start of this, which is really linear algebra. And because what artificial intelligence is from a mathematical sense, maybe this is an oversimplification, but it really comes back to dot products, matrix multiplication, even the tools you hear about the various GPUs and all that, because what essentially is a GPU, that kind of computer, is simply a machine which can do a lot of matrix multiplications, because a lot of data.
Just narrow it back. You know what we study here most, like in mathematics, it stops at just showing you the math, but they never show you how it applies. If you can go to a second segment, can you try and expand on the direct link between just the mathematics, the ordinary Africa studies, and the AI revolution, and how they link together? Because I think most people study math and it just ends there.
Yeah.
Sure.
Yeah, I think that's a very interesting one. So I'll make maybe an oversimplification of it. So I think the most interesting mathematical concepts, especially for the whole AI revolution, maybe I'd say 3 also. But there's a lot of things which are built upon it. But I'd really say the fundamentals of calculus, which it comes in terms of derivatives and in terms of functions and
the YDX?
Yes, what most people commonly, I think, refer to as the YDX. And then you have a very huge branch, which is linear algebra.
That's all level math?
Linear algebra, I believe. O level math. I think we study matrices and vectors in O level, so that should really fall in place with that's probably O level math. At least the basics of it is O level math. But probably someone who studied an advanced degree, maybe in upper high school, probably might be more familiar with that. So that, and then finally statistics, which is really the backbone of it. So the question really goes to, how is data represented? How is the image, your photo, for example, how is it represented in the computer? We all know it's zeros and ones, but really, what does that mean? What a computer is trying to do is to put the structures of your image in and formulate a matrix out of that. Now, a matrix will represent various features into this particular image of a person, right? So, the best way to give an example, let's say you had letters, you had, say, a sentence, so say a word, let's say, not really a word, let me use another example. Let's say you had something which you had something which is which is something which is like the zeros and one examples which I had given earlier. So are you female or male, right? So if you're female, we can say we assign 1 to that. And if you're male, we assign 0 to that.
Yeah.
So if you now have a number of people and you have a string of zeros and ones, you can now know that this is female, this is female, and this is male, simply because you've decided to get a mathematical way to represent that kind of data. Now, that is only for 2 values where you give it this or that. You could look at how you can make this even bigger in terms of if you had more things to try and represent. So what computers are simply trying to do is to now take the female and male example. We have now represented it in simple terms, zeros and ones. They're trying to represent any kinds of features into a matrix. So then eventually, once you have a matrices using these various methods, what the machine is simply trying to do is to do matrix multiplications. And what eventually it is trying to optimize what one matrix is versus another, which is the multiplication gives a result, and that result is then eventually pulled out to get some of the results that then you get to see. But fundamentally, what it simply goes down to is representing data in form of matrices, and then you have things such as vectors which are really positions in space, and really that kind of multiplications is what moves from one thing to another. And then another very fundamental thing you add to that is probabilities. Probability is the likelihood of one thing happen versus another thing happen. So you then come to assign probabilities, because a lot of the foundations of artificial intelligence really actually come from really very old methods in statistics that you're trying to, like I mentioned, like I had explained earlier in the example of large language models. You're trying to assign a probability to what is the most likely word which is going to appear after this particular one. So really a combination of all those particular, I think those three important factors, and put them together, and that is really how you come up with what we now refer to as the modern artificial intelligence. So really the thing I think to go back to more specifically what you mentioned, that how does this translate, is because in school, and maybe I don't even blame the teacher so much, they probably do not know the applications of this system, because which is because when someone teaches you a matrix, they probably don't even know why are they studying a matrix and what a matrix is. But a fundamental thing about matrices is a matrix is the way you represent data. It's a very efficient way to represent data in computers. And I think there's some examples in mathematics which we also capture that. Some of those exercises we used to do, someone maybe bought mangoes, they bought pineapples, and also you have a matrix which is saying this is for mangoes, pineapples, and all, you put those values in. So you're trying to do that kind of multiplication to see what is the eventual cost if one mango costs this, and what to try and do that kind of optimization. So really that is the key importance of matrix, because without that AI is not possible. That is one of the fundamental concepts which really bring about AI. Matrices, vectors, and then really also the whole spectrum of statistical methods, which is those applications, mostly probability theory and really a lot of the concepts in statistics which bring that about. So the fundamental aspects of AI are really mathematical in nature, and they are really grounded in those kind of technicalities, and which I think it's important to talk about this, because especially for policymakers, and really when we start saying things like what is the policies we are looking up around AI, is we need to first go back to understand what even AI means in its fundamental aspects. Because matrices, vectors.
I think that's very important. And in the second segment of the podcast, I wanted us to get into those nuances on the specific challenges that our lived experiences as African communities have, and how we can move away from just studying for the sake of studying and being receivers of civilization as it comes. Join us in the second segment as we continue this conversation.
Welcome to the Parliament Performance Tracker platform, a portal designed to empower Ugandan citizens with valuable insights into their parliament's performance and financial landscape. Some of the key highlights of this platform include the Parliament Legislators Report Card. Here, you find comprehensive information on the members of the Ugandan Parliament, from contact details and their biographies to their legislative performance, including bills sponsored, bill participation, term count, and the number of parliamentary committees they sit on. This section provides a transparent view on each legislator's contributions and activities. The Finance Tracker. This consists of two powerful tools: the Budget Tracker and the Debt Tracker. The Budget Tracker displays the current budget allocations of Uganda, allowing you to track how public resources are distributed across various sectors. But that's not all. There is also the Budget Simulator tool, enabling you to actively participate in the budgeting process by simulating your preferred resource allocations. While the Debt Tracker provides insights into Uganda's national debt standing, you discover key metrics such as the debt per citizen, GDP per capita, and per capita income, along with the sources of these loans. Stay informed about Uganda's financial health and the implications for future generations. Insights. This is a platform where you can gain valuable knowledge about Parliament-related topics. Simply enter your queries and our system will fetch relevant articles and also provide AI-generated summaries, offering you a deeper understanding of the issues that matter to you. With its comprehensive tools, staying informed about Uganda's parliament and financial landscape has never been easier. Whether you're curious about your representative's performance, want to understand their budget allocations, or seek insights on parliament-related topics, this platform has you covered. Empower yourself with data and take an active role in shaping Uganda's future. Parliament Watch. Your eye on Parliament.
Thank you for listening to the Policy Digest, a Center for Policy Analysis podcast that explores how African societies are governed and how people and their leaders are shaping the future of their communities. For more podcasts, check out our Podbean and YouTube platforms. Thank you.